ad hoc workshop on Raspberry Pi Face, and potentially implications and ideas and applications for developing countries. Hosted by your Centre for Development Informatics, but we've not really added a great deal of value because Andy Rolls is the person who is going to tell you all about the technology and what's going on at Manchester and so forth.
All right, thanks, Richard. So I'm Andrew Robinson. I'm from across the road, the School of Computer Science. First question: who's heard of the Raspberry Pi before? Few people. Anybody got a Raspberry Pi? Play with it. So, in which case, for the people wondering what a Raspberry Pi is, this is a Raspberry Pi. So it's about credit card sized. It's $25, and that is basically a simple PC. So you just plug a keyboard, plug a mouse in, and plug a monitor in, and you've got a computer. So you can pass that round if you want. Well, I was thinking to go that way. So the project started from Cambridge University, and the idea was they wanted to get more students doing computer science. So it was very much aimed at getting people into computer science, and they saw it as if they can produce a computer for $25, then children can have them, and they can, in the UK, they can play with them. It doesn't really matter if they break it and they experiment with it, and it would get more people into computer science. And then somebody called Rory Kettling-Jones, who works for the BBC, you've probably read some of his articles, came across it, announced it, and it took off. Well, it exploded basically. So Cambridge were expecting to sell about 10,000 of those units, and so far they're on for target for 1 million to be shipped. So people have discovered that there's all sorts of things that you can use it for, and it's become not just a tool to teach people computer science, it's also become a tool that you can build interesting things with it, and that's basically what I'd like to get talking about later. So, in terms of how it fits in with less developed countries, I feel that it's a cheap hardware platform for a computer, and that way it's a desktop, and also it's become an embedded platform, so it can be used to measure things, control things. You could maybe put people have built a mobile phone infrastructure using them, and it becomes just a really cheap way of bringing the technology out there. So, at this point I can just introduce Tom.
Hello.
So Tom is currently working on Raspberry Pi. He's an undergrad who's done some of the development, and Tom's also worked on the Kenyan orphanage. In fact, I'll just let you talk about it.
So yeah, as Andrew said, I've worked on the Pi-Face project with them, developing resources for sort of demos and schools and materials around it. And as also we said, the last 2 summers I've been to Kenya with the Kenyan orphanage project, seeing the sort of the projects and the schools going out being built. And when I was in Kenya, I went to a school called Alendu, and the headmaster, the COPA's built them a brand new computer room, but not provided any computers, as it's not really their mission statement. But so the headmaster recognised me from the year before and knew that I did computer science, and sort of took me to a corner and said, get some computers. And obviously the logistics of getting a big tower across, just one of them is difficult. So I thought, I'll try, see what I can do, but probably not going to happen. And then I came back and someone told me about the Raspberry Pi, and thought, fits the bill really. So yeah, the great thing about the Raspberry Pi is that, as Andrew said, you can't really go wrong. I mean, we've gone wrong before, but all you do is, the hard drive is on an SD card, and you just wipe that and start again, basically. So I think that's one of the main reasons, other than it's cheap, uses very little electricity, the maintenance is really simple, basically. So yeah, it's got Ethernet, USB, audio, HDMI, and it's powered by sort of the standard smartphone charger. So how can it be used in Africa? The great thing about teaching the kids in Kenya is when you find a subject that they know anything about, they know everything about it. So they've obviously been given medical textbooks far above their age, and a lot of the students that went with me were medics, and they knew a lot more about some things than they did. But they knew everything about, for example, the circulatory system, but then didn't know that you had a skull, you have bone in your head, and that your spine is made of separate pieces. So there's obviously anything they can absorb, they're absorbing, but they're not given everything. And so if you had Raspberry Pis connected to the internet, you can imagine, you know, just trawling through Wikipedia for as long as they want to, really. So the thirst for knowledge is there, it's just getting the knowledge there. Again, international qualifications, just for, you know, job prospects and employability. And then general computer skills. We sort of don't want to leave Africa and Kenya behind, so they're going to have to sort of catch up to the 21st century. So it's sort of necessary to educate the children in what the world scene is going to be like. And then an idea I came up with today actually was pen pals. So it's very much a reciprocal arrangement that children in the UK can learn about customs and cultures over there and languages and vice versa. And then with communities they can gain skills and employability again. And then the Pi face. So as Andrew said, I've been working on the Pi face. It's an interface board for the Raspberry Pi that allows you to have inputs and outputs, so buttons, LEDs, pretty much anything electronic you can imagine. And this is great for teaching computer science because it gets kids interested straight away. If you've got buttons and LEDs, it's better than sort of hello world on the screen. So it'd be great to take some Pi faces to Kenya as well, especially with some of the sort of the more advanced applications that there is possible. So recently there's been a lot of research into cheap medical electronics. So there was on TED Talks, there was a talk about anemia tests. So I think it's about 10 people die of anemia, 10 mothers and children during childbirth die of anemia every 5 minutes. And it's almost certainly due to, so it's postpartum hemorrhage and it's due to anemia. The test for anemia requires a $10,000 machine. But as soon as you know you have anemia, the pill is very cheap and it's widely available in India and Africa. So it's just testing, it's just the machine, the needles, the staff. So they've developed a little, very small piece of electronic equipment that can send light pulses through your skin and then record the data and from the data text whether you've got anemia or not. Lots of other medical sciences coming out with the same sort of approach to cheapness and easy to use. And then if we could have electronic devices like the Pi face, so have the Raspberry Pi there for sort of education and other uses, and then also when it's necessary, use it for other things, such as well water depth and anything you can imagine really, anything in any sort of sensor. So another point is that we want to give the children of Africa the same sort of opportunities and environment that children over here get. So we want these sort of activities and games to these sorts of places and people. And also just, it's not quite the World Wide Web yet, so it'd be nice to sort of finish it off. Thank you.
So basically, I'll just sum up. What we see is the Raspberry Pi providing three opportunities. One is as a sort of standard business machine, so that you can, like Tom says, take the World Wide Web out to Africa, so that becomes part of the World Wide Web. And it's a cheap way of providing terminals for people to use, either internet browsers or office tools. So that's number one. Number two is, as Tom was saying, about the monitoring medical applications. It's compute hardware that you can easily interface with other things. So if you can think of something that you might want to sense, then you can measure it with a Raspberry Pi, and then you can do some data processing, and then you can do some sort of response. Because it's got the connectivity, then you can tie that in with the internet, you can make it talk to different communities. One of the examples which is being worked on is London Zoo is sending some Raspberry Pis out to Africa there's a camera which fits on it and they can monitor what the wildlife is, and that sends data back to the UK where it ends up on your iPhone, and then people can say that's a wildebeest or that's a person or... and so that's just an example of data collection. You can also go to the next stage, you can make it drive things, so you can automate if a machine, or it's basically a computer that you can put in something and you can make that computer drive something or measure things. And then the third thing that we talked about was basically we see it that this is the same tool that's going to be used to teach computer science and technology in the UK. It's that affordable, why can't it be used to teach in other areas of the world, and then that way it gives them something that they can either trade or some sort of knowledge economy. And so, yes, you've not seen this. This is the Pi-face interface that Tom mentioned. This is the thing which sits on the top of the Raspberry Pi, which is the thing which enables it to take inputs, outputs. So this is what we're saying, it makes Raspberry Pi talk to the world. So that's what we've developed, and that's our particular contribution. So I suppose really hopefully that's given you some ideas about what the platform is, what it can do, and we'd be interested to have a bit of discussion or hear what your ideas you might think are. I've got a definite idea for that. I can make it automate my coffee machine, or you know, if you've got any other applications, or whether you just think that it's completely the wrong thing, then say. So any questions?